So let's review some terminology. Remember that exterior angles lie outside of the two lines. Interior angles lie between the two lines. If the angles are on opposite sides of the transversal, they're called what? Alternate. And then if they're on the same side of the transversal, they're called consecutive. Corresponding angles are angles that are in the same position. So like 2 and 6 are corresponding because they're both kind of like on the top of its little cluster of angles. Okay, so we're going to kind of go through this problem with the given information is the M and T are parallel, and you're also told the measure of angle 1. Okay, so I'm going to mark on the picture that we know that those are parallel lines. I think I told you in section 1 that, that we showed lines are parallel by putting the arrows on it. Sometimes you'll see them like these kind of arrows instead. It just sort of depends on the book or who is writing the drawing the picture. And then I've also told you that angle 1's measure is 60 degrees. So that's the given information for this problem. I want to look at the little cluster here of angle 1, 2, 3, and 4 and figure out the other angle measures. Okay. Jack, tell me what one of the angle measures is so you can figure out.
3 is also 60 degrees.
Because why?
Because
good. So angle 1 and 3 are vertical angles. Vertical angles are congruent, so we also know angle 3 is 60. Okay, how about angles 2 and 4? Because why?
Because angle 1 and angle 2 are linear pairs, so 2 would be 120 and 2 and 4 are vertical.
Good. So we have 2 as a linear pair with angle 1 and also with angle 3, so they have to be supplementary. And then you can do the same thing with angle 4, or you can just say angle 4 is going to be congruent to 120 above because the vertical angles are congruent. Now that those 4 angle measures, did finding those 4 angle measures require us to know anything about parallel lines? No, right? We use vertical angles are congruent. We use linear pairs as supplementary. That had nothing to do with parallel lines. However, if we try to jump down to this other group of angles down here, we're going to have to use the angle measures that we've got up above. What do you think angle 5's measure is going to be? 60. That's actually an assumption, right? We're going, because those lines are parallel, it makes sense that if you have a transversal cutting through them, then those angle measures will be the same. That's an assumption, so that's a postulate. Okay, the postulate, because we have to have like a basic to assume to build from. So this is a postulate. If I'm going to make a little symbol that means parallel lines cut by a transversal. Okay, this little symbol, because this is parallel lines, right? Like if I say L is parallel to M, that's parallel lines. And then cut by a transversal. Okay, that you read that as parallel lines cut by transversal. And that's just so you don't have to write this out all the time. Okay, so that little symbol means parallel lines cut by a transversal. So the postulate we just used is if parallel lines are cut by transversal, then corresponding angles are congruent. Now again, those are corresponding because they're in the same position. Right? Angle 1 and angle 5 are both sort of on the left side of their little cluster of angles. Now, if we kind of finish that off, we could do the same thing as up above. We could use the vertical angles there have to be congruent. So that one's also 60. And then we can use that these will have to be 120 for the same reasons as they were above, or because we can transfer the angles above down to this group down here. So we could say that 120 is congruent to its corresponding angle, etc. Okay, but when we jump from the top group to the bottom group, we have used that the lines are parallel. So the first postulate was if parallel lines are cut by a transversal. Now they've written it as if a transversal intersects 2 parallel lines, you can say it that way, or you can say it as I wrote above, but I'm going to use that symbol. If parallel lines are cut by a transversal, then corresponding angles are congruent. Okay, so you would write, if parallel lines are cut by a transversal, then corresponding angles are congruent. I'm going to draw a little picture here for us to look at. So we're going to have two parallel lines, except I don't have a line of the curve. Okay, so we're going to have two parallel lines. And here's a transversal. And I'm going to call these angles 1, 2, 3, and 4, and 5, 6, 7, and 8. Okay, so give me an example of corresponding angles in that picture. Rachel, give me an example of corresponding angles that would be congruent in that picture. Angle, say it again. Okay, angle 2 and angle 6. Angle 2 and 6 would be corresponding, and then therefore they're congruent because the lines are parallel. When I ask you to justify these ideas, you have to make sure you don't just say, oh, they're congruent because they're corresponding angles. Remember that in section 1, you did not have parallel lines, you just had two random lines. So there were like two lines, and then there was a transversal. And we talked about how like this angle and that angle are corresponding because they're in the same position, but they're not going to be congruent if the lines aren't parallel. So the main difference between what we did in section 1 and what we're doing now is that we still have that same terminology, except that now because the lines are parallel, we can also talk about the relationship between the angles that are formed by the two lines in the transversal. Okay, so the second one, alternate interior. Nyla, name a pair of alternate interior angles. 4 and 6. Why are they alternate interior? Okay, they're interior because they're between the two lines and they're on opposite sides of the transversal. So those would be alternate interior. So if I ask you to explain why angle 4 is near to angle 6, you say, if parallel lines are cut by a transversal, then alternate interior angles are congruent. And an example of that in the picture would be angle 4 is congruent to angle 6. Sydney.
When you ask us to explain this, do you mean like if you were to like just ask us the definition or like on the picture?
So these are theorems, postulates and theorems. So you're going to see on the next group of problems, we will set up equations to solve for a variable, and you're going to have to justify your equations, like how you know they make sense. You might also see it as an approved. So yeah, these are like the theorems that justify how you know that those angles have that relationship. Consecutive interior angles. Consecutive interior angles. Ainsley, name a pair of consecutive interior angles. Four and 5. You don't sound very sure. Explain to me, convince me that they're consecutive interior. Same side of the transversal, and they're both interior angles, okay? So why were you not sure? Okay, so 4 and 5. So if we look at angle 4 and 5 up here, which are, they're also consecutive interior angles, how are angles 4 and 5's measures related? Are they congruent or something else? Stop. They're supplementary, right? So that's going to be true anytime you have consecutive interior angles. So this one would be if this theorem is if parallel lines are cut by a transversal, then consecutive interior angles are supplementary. I'm writing this one in a different color because this is supplementary rather than congruent. I want to make sure you distinguish between the two. Okay, name another pair of consecutive interior angles. Megan, name another pair of consecutive interior angles. 6 and 3. So for example, the measure of angle 6 and the measure of angle 3 equals 180. The measure of 6 plus the measure of 3 equals 180. So again, they are supplementary. What about consecutive exterior? So in that diagram, Johnny, name a pair of consecutive exterior angles. One and what?
1 and 8.
Angle 1 and angle 8 are consecutive exterior. Okay, are they congruent or supplementary? (60 and 120), are they congruent or supplementary? Angle 1 and angle 8, 60 and 120, are those congruent or supplementary angles? They're supplementary. Okay, and normally I don't tell you, normally I tell you, don't go by how the picture looks, but with the parallel lines problems, if it's really drawn where the lines truly look parallel, then honestly, you can kind of go by how it looks. So it is believable that in this picture, a pair of consecutive exterior would be like 2 and 7. They clearly don't look congruent, right? 2 would be congruent to 6 because the lines are parallel, and 2 and 6 are what kind of angles? They're corresponding. So 7 has to be supplementary to 2 because it's supplementary to 6. Okay, so this is true whether they're consecutive interior or they're consecutive exterior. For some reason, your book doesn't really give you a theorem for consecutive exterior, but we can certainly use that. So consecutive exterior angles will be supplementary when the lines are parallel cut by a transversal. Okay, so the consecutive ones, whether they're interior or exterior, the consecutive ones will be supplementary. Okay, and then that would be, like I said, angle 3 and 6 would be for interior. A consecutive exterior would be like 2 and 7, for example. Yes, because it's an equation. If you write angle 6 and angle 3, angle 6 plus angle 3, that's improper notation because the angles themselves are not actually being added, it's the measures of the angles. So the measures are numbers. That's annoying. I think they're getting close to being done with that door. Last theorem. If parallel lines are cut by transversal, then alternate exterior angles will be congruent. Sabrina, can you name a pair of alternate exterior angles? 8 and 2. Yep, exterior, then on the opposite side of the transversal. So something like angle 8 is congruent to angle 2. All right, we're going to write the statement of the postulator theorem that justifies why each of these things are true. So tell me how you know. Again, we've got parallel lines here. So we know that the lines are given to be parallel. How do you know that angle 3 and angle 7 are congruent? Scott? Okay, so I can't just write corresponding because it says write the statement of the postulator theorem. So I'm going to write what? If parallel lines are cut by a transversal, then corresponding angles will be congruent. Okay, how about 3 and 6? So 3 is here, 6 is there. Jordan, tell me what that theorem would be. If parallel lines are cut by a transversal, then alternate interior angles are congruent. Good. Okay, and then for 2 and 7. 2 is here and 7 is there. Oliver, give me that one. Okay, but I need the whole thing, not just the ending part. Okay, and again, the reason you have to write the whole theorem is because alternate exterior angles are not always congruent. Again, back in the last section, you had lines in a transversal. That one and that one are alternate exterior. However, they're not congruent if those lines are not parallel. So again, you need to make sure that you're qualifying the statement by saying, if you know that the lines are parallel, then you'll have alternate exterior angles that are congruent. Okay, and then how about 4 and 6? Meg, how about that one? They're on the same side of the transversal. So they are interior, but they're what? Yeah, they're consecutive interior. Okay, so if parallel lines cover transversal, then consecutive interior angles are supplementary. Okay, now the next kind of problems, the problems on the second page, we are going to solve for the variable, and we're also going to write the justification for how we know that our equations make sense. So again, notice that they have given you parallel lines on the diagram. All of those have parallel lines given. So rather than writing it out, they're showing you on the picture. Okay, how are these angles related? Andrew, how are those angles related? They're corresponding. So they're going to be congruent. So 3x plus 3 times the quantity x plus 9 is 129. Tell me the theorem that you would write. If parallel lines cut by transversal, corresponding angles will be congruent. So that's part of your answer, and then your solution is your other part. You can either distribute or you could divide both sides by 3. 3x is 102. Do we know the divisibility rule for 3? Catherine, what's the divisibility rule for 3? Okay, I'm checking whether 102 is divisible by 3. Good. So that's a helpful thing to be able to quickly check whether you should expect your answer to give you whether it will divide evenly or not, right? So because 1 plus 0 plus 2 adds to 3, if the sum of the digits is a multiple of 3, the number itself is a multiple of 3. So it should go in evenly. It'll go in, let's see, 334. Okay, how about the one over here? Nyla, tell me what this relationship is. Alternate what? Interior. Okay, so tell me, how are they related? If parallel lines cut by a transversal, then alternate interior angles are congruent. Okay, so since they're congruent, we're going to set them equal. So 80 will be equal to 5x minus 15. Add 15, divide by 5. X is 19. Okay, but again, notice that we're not just writing alternate interior angles are congruent. We're writing because the lines are parallel. Okay, if there's parallel lines cut by a transversal, then alternate interior angles are congruent. All right. Zach, tell me either X or Y's value and how you know. X is what? Okay, so this is a line, right? Does 98 plus 98 add to 180? Okay, what did we just use? How are these angles related? What do you call those angles? That's a linear pair, right? So what we just used is that 98 plus X adds to 180, and therefore X has to be 82. This is a theorem from the last chapter. Linear pairs are supplementary. Okay, so this one is not actually using the parallel lines at this point. So sometimes your reason might be linear pairs are supplementary, or maybe it'll be vertical angles are congruent. It does not have to be one of these new postulates theorems. Okay, and then what would Y have to be? Evie, what would be the value of Y? Because Y? Good. So she's using the alternate exterior angles. Thank you. So 82 and Y are alternate exterior, and they will be congruent. So Y will equal 82. Now, you might notice that there's more than one way you could do this problem. You could also have, for example, used those two angles are what kind of angles? Not corresponding exterior. Consecutive exterior. Okay, so because they're consecutive exterior, they should be supplementary. So you could use a different reason here. It would still be 82, but you could have a different reason. So on these problems, there can be multiple ways to explain, but of course your values for the variables should be the same no matter how you do it. Thanks, Kylie. Okay, and then for your last one here, Sarah, how are these angles related? They are consecutive interior. So if parallel lines cut by transversal, consecutive interior angles will be what? Will be what? They'll be supplementary. Again, normally I tell you don't look at what picture, how it appears, but honestly, with the parallel lines, if they're actually drawn to look parallel, you're going to know that those aren't congruent. Right? They should be supplementary because 75 would be the same value as the corresponding angle down here, and then these guys are a linear pair, so they'd have to add to 180. Okay, so you could either say, oops, sorry about that. You could either say 4x minus 9 plus 75 equals 180, or you could do, because this one's 105, or sorry, 75, this one has to be 105 to make them supplementary. So if you want to kind of do that part in your head and then just say 4x minus 9 has to equal 105, that would mean 4x has to equal 114. And that does not divide evenly. It'll be 28.5. Okay, so again, two parts to our answer. X is 28.5. And your reason is if parallel lines cut by transversal, then consecutive interior angles are supplementary. I kind of left out the then, but it really should probably be this. Okay, here's a proof. This proof is maybe a little different than some of the other proofs that we've done. For this proof, you have some given information on the picture that's not actually stated as given. Notice that we know that these lines are parallel, and there's a second pair of parallel lines also in the picture. That's kind of given information on the diagram that's not actually written over on the side. Okay, what we're supposed to be proving is that the measure of angle 1 is 75 degrees. So it's given you that angle 6 is 105. And we're going to kind of work through using the postulates and theorems that we know how we can jump from angle 6 over to angle 1. 6 and 1 are not directly related, but we can kind of go through another angle to get there. All right, how do you know that angle 1 is congruent to angle 4? What would be the reason why angle 1 is congruent to angle 4? Lucy, tell me the reason why angle 1 is congruent to angle 4. Could I just write, because they're, what kind of interior angles are they? Mark, what's the name of, oh, she got it, okay. If parallel lines covered by transversal, then alternate interior angles are congruent. All right, how do we know that if 1 and 4 are congruent, then the measure of angle 1 equals the measure of angle 4? Luke? That is definition of congruence. So you're going to see things from the last chapter that are relevant here. And so that will be helpful to remember everything from the last chapter. And that's a little different than maybe you've experienced in the past in math. A lot of times you kind of learn disparate things. You don't necessarily have a lot of crossover. In geometry, there's always going to be things that you learned before, whether it's vocab or whether it's Postle's theorems, ideas that will keep popping up later on as you learn new stuff. Okay, so we use step 1 to get step 2. Where is step 3 coming from? 4 and 6. 4 and 6 are right there. Where's that coming from? Evie? Good. Consecutive interior angles are supplementary. Okay, and then how do you know that the measure of 4 plus the measure of 6 is 180? Sydney, what's the reason for number 4? Four and 6 are what? They're not linear pair because they're not adjacent. They're consecutive interior. But you're actually going from the previous step. If they're supplementary, how do you know they add to 180? Yeah, that's just definition of supplementary angles. Okay, so we used 1 to get 2, but when we used 3 to get 4, we really haven't used step 2 yet. So where is step 5 coming from? What's the justification for step 5? Jordan? What are you substituting? Okay, so we're going to take out angle 4, put angle 1 in its place because they're equal, right? So we use 2 and 4 together to get 5. Could that have been transitive or just substitution? Just substitution. Okay, and then angle 6 is 105. Where did that come from? Measure of angle 6 is 105. Andrew? That's given. This might be one of the first proofs where we didn't actually start with the given and it's brought in later on where it's actually relevant. We kind of indirectly started with a given because remember on the picture, we were told the lines are parallel and that's how we knew that we could use the congruent alternate interior angles. So although we didn't explicitly state it, we were given some information that we used in step 1. Okay, where is step 8? Oh, notice I removed step 6 because it was something that didn't matter. It was totally irrelevant, so I just took it out. You're wondering what happened to just step 6. Okay, what's going on with to get step 8? Catherine, what are you substituting? 105 is the measure of angle 6, so just replace that. And again, that would be substitution. Is it possible to call it transitive? Same reason as before. It's not able, you're not able to call it transitive because you're just simply substituting in place of one of the terms here. So it's like if this and this, then this. So we're not replacing a whole side of the equation, we're just replacing one term. So if you're only just substituting in for one term, then it's substitution, but it's not transitive. Okay. And then last step. Sabrina, what's the last step? Subtraction. What are you subtracting? 105 on both sides. Okay. Now that's a long way to kind of figure out that the measure of angle 1 is 75, but that's the kind of thing you would think through. Like that's the logical progression. Okay, this last proof, A is parallel to B, is given. We're trying to prove angle 1 is congruent to angle 7. So if we're trying to prove angle 1 is congruent to angle 7, and we're somehow using vertical angles along the way, what vertical angle are we using? We're trying to prove angle 1 is congruent to angle 7. Nyla, which vertical angle? Angle 7 and angle 5. So we know we're going to want to say angle 7 and angle 5 are congruent so that we can join 1 to 7. What should step 2 say if we're using corresponding angles? Angle 5 is congruent to angle 1, and then it's transitive, right? We're using angle 5, taking that out and getting angle 1 is congruent to angle 7. I know that on this proof, they've written that a little differently. I'm going to expect you to write if parallel lines are cut by a transversal. Okay. I let my academic students simplify that a little bit, but not you guys.